Okay, in this section, I'm going to show you how to do design using Midas General. You can see here on the screen. Let me show you the problem statement firstly. So this is the design example that we used in class. Basically, it's a cantilever truss, and we are given all the slow loads or any dead loads, including the self-weight of the roofing, self-weight of the purlins, as well as the self-weight of the truss weight over here. So now I'm going to show you how to create the model of this cantilever truss, as well as to show you how to apply a dead load and live load, and the slow load separately, which is a little bit different from the first video that I shared with you, where we only applied all the loads or the combined loads. But here, I'm going to show you how to apply the slow load and the dead load separately on each joint, as we calculated in the example over here. Okay, so and then after the structural analysis, I'll show you how to do analysis here. So now let's open a new project in Midas General. It's next time. Oh, okay. So we have the Midas General open. Let's select the structure type firstly, because we want to do the two-dimensional charts in XY plane, because that would be easier for us to input to the grid coordinates here. So that's the structure type. Then we create the grids, the line grids. So since we will have the 10 feet the spacings in X and the 3 spacing in the 2, so basically we will have 3 10 feet spacing in the X direction. Let's check what's the unit system here. See, unit system. Okay, it's the should be feet. And then we add the grid lines. Okay, so firstly we have the grid name, just and then we add 3 10 feet grids here, and the Y we have 1 3 feet grids here. That's a grid system we have. We have all the grids here. We close. So then we can show the XY plane. So that would be a top view. We have everything here, and that's the grid system. So now we can, before we do anything, we just save that everything here. So that's the top chord line. So that's everything we have here. So then we could create the members. So we go to the element here. So we need to create members. So basically, all the members will be the truss members here. So we have everything here, and then we start creation. So as you can see here, we can start. So from here to here, and from here to the 10 feet. Where is the 10 feet? Okay, 10 feet. Okay, we will show everything here. 2 feet. No, no. Okay, we redo that again. Have 10 feet. Okay. Okay, you have everything here. Yeah. pick this point, that point, this point. So we have those two members from here to here. Oh no, it's not working, but the bottom chord here. Bottom chord is down, and some interior ones. Oh no, it's not working, but we could pick the grid lines. We can only pick the grid lines, but automatically make some joints for us. So now we pick this one, this one. So I think that's the structure system we have. Now let's check. And then we have everything here, and we have everything here, but looks like the 5 and 9 is not needed. Right? We can just delete 5. Okay, just select the single 5 and 9. So you can click Control to pick both of them and delete both of them. Apply. Yeah. So yeah, delete it here anyway. So now we save the model. So that's a structural model that we're gonna work with to do design as well as to do analysis here. So that's the information we have here so far. So then next step, we go to properties. So we know that, okay. So for the top chord, we will use WT, and also for the material, we will use A36. So we need to define a material called A36. That's a steel. It's called A36. So ASTM, enable database 36. So that's the material we have here. Then we're defining a section. We need to define a WT for the top chord. WT. And the T section. We can use any WT here. So for example, we can have a name called top chord. So we have a section database from AIC. We wanted to define a WT. So we can pick any WT. Then such as we can pick any W7 here, and later on we can update it. So that's the WT for the top chord we have here. So that's a top chord. So since in this example we will only design the top chord, so we could use the top chord for all the members. And so in the future, we could work more on to design the bottom as well as design the diagonal or vertical ones. Here, that's adequate here. So then we would like to assign as section properties to all the members. So we wanted to change, and we wanted to change the element. And we want to change all the define all the element code. But before we do that, we can show the element names. Right? So we can show the element names, show all the property name, see whether we can have everything. Oh, so everything is top chord already. So it automatically define everything as the top chord. So we are ready to move to the next step. We define the boundary condition. The boundary condition for the top, that's a pin, right? Top, that's a pin. So we wanted to restrain the top, the bottom, right? And to pick the top and apply. So that's the pin. Bottom, we wanted to restrain only the X direction. So that's the bottom one. So let's save this. We wanted to, and then we can also show how the boundary condition looks like, such as so there are some numbers showing the under boundary conditions here. So that's it. And then we can apply the load. Okay, so we apply joint load as the interior and the exterior joints over here. So we need to define two load cases. So the first one is called dead load case. That's a dead load. Okay, add here. Then we need a slow load case. That's a slow load. And this is important for multiple types of loads here, because as soon as we define the load types here, the software can do the load combinations automatically for us. So it's important, especially when you do a real world design over here. That's all we have over here. And then we can apply the load, right? So structure load, then we have the check, what is that? Dead load? No. The dead load, we have already calculated in class. Right, so that, okay. No, wait. So the dead load for exterior loads, that's around 1,000. The slow load is also calculated here. The slow loads for interior ones, such as joints B and C, would double the values over here. Right, so that's what we have here. Let's check the unit firstly. Unit is in kgs and foot, so we'd better to change to pounds since we have already everything in pounds. So as soon as we have everything in pounds here, so next step is to apply the load. So remember for the interior ones, we have the double the load values. So here, and let's go to the load, and we apply the loads, pick the exterior ones. They are shown here. And when you apply load, we need to check the load case. So this is the dead load, and then we have the Fy as the 1106.5. It's the dead load we have. That should be minus because it's downwards. We have the dead load here. And then we would like to apply that slow load for those exterior joints too. Slow loads here and here. So 1 minus 1250. Yeah, so we have all that. And then the slow loads, and we can show the values here. If you want, we can show the values, know the values, case selection, such as dead loads. Oh, that's not. Oh, we forgot to press the apply. So that we have to redo that anyway. So this is the slow loads here, here. Apply. As you can know, it's applied. Oh, to here and here, and looks like we double. Right. Okay. So now it's back to normal. Right. So this is the slow loads. Now let's see. How about the dead load? Oh, the dead load is not showing here. Oh, no, we did not show the load. Okay, the dead load's there. The slow node there too. Okay, is that correct? So now we apply the interior ones. So we should. So you may want to show the. You may don't want to show the shape here, so we can close the shape. Okay. So for the element, okay, property. Okay. And there should be a way to close the profile here, but let's see. Okay, we're gonna do that later. That will not affect our design over here anyway. So we have the exterior ones. Now we apply the interior nodes, such as the slow node for the interior ones would be minus. It will be double that. So we select the interior one. Oh no. I want to select. Oh. So we can use this one to select the interior one here and another one right here. So we apply the interior slow nodes. Then we wanted to apply the interior dead load here. Dead load would be so 1106.5. That should be 2213. The dead load over here. So we select this one, select this one, 2, and apply. So that's it. So we can check that. Before we check that, we save it and check the load values such as the dead load only. That's the dead load, as you can see here. The dead load for the interior joints will be double dead loads on the exterior ones. And we can also show the slow load here. Okay. That's everything here, So now we save it, and then we can do the analysis. So we have the truss, we have the geometry and the section assigned to each of them, and we have the loads, and then we have already defined the boundary conditions. Should be ready to go. And we perform the analysis. And it says analysis is done here. So let's see, we can check the results here, such as we can show the truss forces for each of the truss here, such as the values. Show that. That's all the values. That's for dead load. We better uncheck the section properties so that everything will be clear. So that's the dead loads and the slow loads. I'll calculate this separately. Okay. So now we need to define the load combinations because when we do design, we do need the load combination. Load combination for steel design. You can either do auto generation, such as auto generation. We just click OK. Oh, no existing, no case. Oh, we have the node case. We need general. It's auto generate. Existing. Design code AIC. Let's use AIC. Okay, that's auto-generated. So, but typically we only need that. But for strength design, we need that top two. So we don't need those. We can just delete all of them. Oh no, we can delete all of them. So while we go to the steel design, we regenerate steel design. Okay, so we do not need the bottom three. That's it. So that's a load. You can check the dead load. That's 1.4 times D. combination 2, that's the 1.6, 1.2 plus 1.6, right? That's all. So as soon as we have the node combinations, we can also check the node values for those node combinations. Oh, where do we have the? Okay, it's coming up over here. Show there are node combinations because we are interested in controlling one. So that's the one we have. Very similar to what we have for the hand calculations. Slightly larger, slightly larger. That's the load values we have here. So then we can do the structural analysis and the design. I think that's brand new. So up to here, everything was pretty similar to what we did in the first video. Here we can do the design. We have everything. Next to the design part, we wanted to have the general design. And there are a lot of general design definitions, but for tension member design, we do not need to define any design parameters. And we can go ahead and do steel design. And do steel design, just design code, and we can change some of them. But here we can just go ahead and do the design code check. So it looks like and the WT works for all the cases since the controlling factor is very small, but we could change some of the design, such as we can select this one, we can change whether we can use a smaller, okay, such as we can have a smaller ratio, such as we could use the W4/12. That's the lighter, and the smaller one can change everything to WT4/12 now. But it's not working. It's not working. We can recalculate. It's not working in this case, so that we can change it. Search for. So it looks like we need to go a little bit heavier, such as I would check that W5/13. Okay, it's done. Oh, it's working now. It's working now. So now we can show the graphic calculation actually, such as you can say how this design is calculated. But here, the section is used for all the different types of sections there. So I would assume the compression controls here. So it looks like a little better to have a different property for the bottom, because the top is under tension, bottom is in compression. So the design would be different. So the next one you can do is to assign different sections. Which, for example, here we can use we can add more sections here to modify the design here. So such as we go back to, say, what's the time? I don't know what to. Okay. Now we can go to the properties, and we would better to unlock the result here. So we go lock the result here, go back to properties. We wanted to define different sections for bottom and top. Add a bottom one. So that, such as the bottom would be also a WT. We have a WT whatever. The bottom one. And we could also define some angles, L shapes for the diagonal and the vertical. Vertical. L angles to pick any L angle here. So that's it, and that's it. So now we assign the different properties. So here we change properties, such as for change element. We want to change the section ID for bottom chord. Just wanted to select the bottom ones. This one. Oops. This one. And this one. I'm going to switch back to the individual select. This one. Change this to bottom chord. Apply. After everything has already been changed to bottom chord. And for those vertical ones, we want to use diagonal. And so we select this one, this one, this one. Oh, there is one. This one, and then this one. These ones will be diagonal and vertical ones. So we assume they will be smaller. Right? That makes more sense because we don't want to. It's better. It's more economical to use different sizes for different types of members here. So now we can check whether we assign the different properties. Then, yeah, they're different. They're different now. Maybe this way we will have a lighter truss. So now we do the analysis again. So it's done, and we redo the design. Line code check. Oh, all of them is working. So now let's say, and then you can check the ratios. Some of them is 0.8, some of them 0.6, some of them is 0.99. So the bottom chord is can be smaller actually. You can check whether we can go smaller. Yeah, definitely we can go lighter, such as we can see whether we can use a lighter one. Yeah, that's a lighter, still working, and the others are pretty much working. Or we can select all of them and do some optimizations later. So it looks like that they are working. They're working on initial design, and then we can optimize that. We can try optimize. If we do some optimization, they are still working over here. So you can see here the top chord, bottom chord, as well as anything else pretty much working. How about the top? We can show the design summary here. Also show the design check for the top. This is the top chord. Show the design check here. So you can see here, and there are some design checks there. Member forces calculated. Console one is at around 100 pounds, and bracing diameter because it's tension member. The axial strength is calculated based on the area over here. So it's kind of calculated here. So that's the design for the tension member. And bottom one is a compression member. We will talk about compression member later. But this is how we finalize the design of a truss member using the software here. I think can also show the section shape. Yeah. So that's the shape, but there should be a way for you to show that property name or the size of the member too. And, I think that's all for this video. Thank you. Bye bye. Close. Stop. Stop sharing. Now I wanted to stop recording.